Hello guys, welcome to Chem Classes. This is my second video. I am Bani Chakraborty. I am also a student and today I am going to make you introduce with the topic motion of plus 9 physics. So without further delay, let's get into the topic. So what is motion? In our everyday life, we get to see many situations such as you bicycling, you walking, I am riding a merry-go-round, or we are hitting the carom board, or something we can say like Earth is moving, and we can see many other examples in which an object is moving from one distance to another in a given particular time. For example, see, this is your home, this is your friend's home, and you are moving. This is the road and you came to your friend's home. It took you, suppose, a time of 10 minutes. So you took 10 minutes to change your position from here. This is position A, this is position B. So we can say that this is motion. In our everyday life, we can see motion in many places. There are many types of motion such as uniform motion, non-uniform motion, accelerated motion, circular motion, non-accelerated motion, and many more. Now, to understand motion, we have to know what is reference point. Reference point is the point of view. According to sense, we can say reference point is the point of view from which you can define motion. Now, let me see you. See, when you are moving, maybe according to you are moving, but according to some other person, you might be in rest. For example, let me see you. You and your friends have planned a picnic trip, and you both are going to picnic in a bus. So you are sitting here, your friend is sitting here in a bus. When someone from outside see you both, according to him, you both are moving. But according to this boy, your friend sitting over here, you are at a fixed place, means you are at rest. So according to this, we can define motion. For example, means here we are in Earth, but when we are at rest in Earth, but when an astronaut will go out of the Earth and he will see from there, according to him, we will be moving, because Earth is always revolving and having revolution. That's why reference point is necessary. Now let us get into the topic of scalar quantity and vector quantity. What is scalar quantity and what is vector quantity? Scalar quantities are the quantities in which we have magnitude only. There is no need of direction. For example, from here to here, this is a road. When a person moves from here to here in this road, there is no direction. See, here it is going in northwest. Here it is coming in southeast, and so on. It is moving, but there is no fixed proportion that it is moving in each direction. It is moving in west direction. It is moving in north, or there is nothing fixed direction. So when a quantity have no direction but only magnitude, it is known as scalar quantity. And now what is vector quantity? The quantity which have magnitude as well as direction is known as vector quantity. Now what do I mean by magnitude as well as direction? Let's see. From this point to this point, which is the shortest distance? Obviously, this straight line between 2 points is the shortest distance. So from here to here, it is the shortest distance between these 2 points. So we have a particular direction. We have a particular direction that this object is moving in southeast direction. We can say that this object is moving in southeast direction for 5 kilometers, suppose. Now let me make it more clear. From here to here, this is the displacement, means the shortest path, shortest distance between any two places, two positions is called displacement. Now between these 2 points A and B, if we tell the displacement is of 5 meter, can we say the direction? Yes, obviously we can say the direction from here to here, means it is from east to west. So 5 meter east. So this is the displacement. But when the road is like this, can we say the direction? Obviously not. And this road is known as distance. Now what is distance and displacement? Let me make it more clear. Distance is any path followed by an object to move from one place to here. For example, you came, this is your classroom and this is your washroom. You say, sir, may I go to the washroom? After that, your sir said yes. And you being somewhat, let's roam and come, we have a tendency of bunking that you would come like this, or you would roam and you would come here. But this is not the shortest distance between your class and your washroom. And those good persons who are there, they will tell that, my God, sir is taking class, I have to go fast. So they will take the shortest distance between these 2 points, that is this. So we can say that the shortest distance that the good persons, not good, but those who want to stay good, you can say like that, those who are mannered, they follow the shortest path, and the shortest distance between this point and this point is known as displacement. And what is distance? Any point, any path between 2 points or 2 positions is known as distance. Now let us see the next topic. As we saw distance, we have to now see what is speed and velocity. These are the 2 terms. Now speed. We hear the word speed every day. What is speed? We can say that the amount of distance an object is traveling in a particular time. For example, in 1 second, an object is moving 5 meters. So how can you say that it is moving with? Actually, speed is the ratio between the distance traveled and the time taken. For example, an object is moving from here to here, distance is 5 meters in 5 seconds. So the distance between here is 5 meters and 5 seconds. As I said you now that the speed is the ratio between the distance traveled and the time taken. So we can say speed equal to distance proportion to time equal to now you see the distance between this point A and this point B is 5 meters, and it takes 5 seconds. What is the unit here? 5 meter, 5 seconds. So what is the speed? 1 meter per second. So from here we can get to see two things. See, unit of speed is meter per second. First observation. Second observation, the formula of speed is speed equal to distance by time. Similarly, let us see about velocity. Velocity is nothing but when an object moves in a particular direction with a speed, the speed turns into velocity. Means it occurs in a particular direction. For example, here to here, it is moving in a particular direction at a velocity or at a speed of 5 meter per second. So this 5 meter per second is the velocity of the object. Now, velocity is also considered as the ratio between the displacement and the time taken. Now let us see the formula. Displacement equal to velocity equal to displacement is to time. As it is the ratio between displacement and time, we can say that velocity is the ratio between the displacement and time. So next what we can write? Same velocity equal to displacement by time. Now here it is moving 5 meter in 2.5 seconds. So the displacement from here to here. See, this is the shortest distance between these 2 points. So it is the displacement. Remember, I said you sometimes ago, shortest distance between 2 points is known as displacement. So the displacement is 5 meter. 5 meter. It takes time 2.5 seconds. 2.5 seconds. 2 meter per second. Clear? From here, what are the observations we can make? The formula of velocity is displacement by time. Unit of velocity is meter per second. See, the unit of velocity is the same as the unit of speed. Now let's see what is acceleration. When we are moving in a bike, we say no, we pull up the accelerator, means we increase the speed. So here we can say that acceleration is the rate of change of velocity. So what do I mean by rate of change of velocity? For example, an object is moving with a speed of 1 meter per second, changes its velocity to 4 meter per second in a time of 3 seconds, suppose. So it is changing its velocity from 1 meter to 4 meter per second in time 3 seconds. So we can easily say rate of change of velocity equal to how much the velocity is changing. 4 meter per second means it is the final velocity, and 1 meter per second is the initial velocity. Final velocity is also represented as v, and initial velocity is represented as u. So rate of change of velocity we can say like that: rate of change of velocity equal to v minus u by t. Yes. So in the case, let us put the values of the case in this formula. The final velocity is 4 meter per second and the initial velocity is 1 meter per second and the time is 3 seconds. Okay. Now if you solve it out, the answer is 3 meter per second by 3 seconds. If you cut this both, 1 meter per second square. Yes. From this, what are the observations we can make? The rate of change of velocity, I said you just now that the rate of change of velocity is also known as acceleration. So we can write acceleration. Acceleration, the value of the formula of acceleration is this and the unit of acceleration is this. So there might be a question in the exam, why second square is there in the unit of acceleration? Because as we know, acceleration is the rate of change of velocity. So here you see, here it is meter, here the unit of this is meter per second and unit of this is second. So this one we can write here as meter per second by second. Solving it, what we get? Meter by second divided by second, that is meter by second into 1 by second equal to meter by second square. So that is why second square occur in the value of acceleration. Thank you.